morning, everybody. Hope all are fine. Okay. So, in the previous class, we actually discussed about dimension and the two applications of any dimension. Okay. Now, today we are going to discuss about another applications of dimension. Okay, significant figure, and also we actually discuss about different errors. Okay, and how we can find out different errors. Okay, so first we have to know about applications of dimension. Okay. So in generally we already know two applications of dimensions. So today we going to our third application, that is application number third, that is deducing the relations among various physical quantities. Okay, this is based on the principle of homogeneity of dimensions. Like, suppose if we want to find out any relation, okay, between different quantities, so we have to know their dimensions. Okay, so using the dimension we can easily find out the relation between different quantities. Like, suppose we have to find out what is the relation between time period, length and acceleration due to gravity. Okay, so at first we have to take in time period t is depend on length and z. Okay, how? Actually we just take t proportional l to the power a and g to the power b, where a and b constant. Okay, now we have to know what is the dimension of these quantities. Okay, first time period, it is actually time, so the dimension of time period is equal to t. Okay, t is equal to constant k into l means length, so dimension of l is l to the power a, and g means gravity, that is acceleration, so the dimension of g is l to the power minus 2 to the power b. So if we solve the equation in the right side, we get k l to the power a plus b into e to the power minus 2b. Okay, now we compare both sides. In the left side there are no term, that is l, so we can say that comparing a plus b is equal to 0, and also we can say that minus 2b, that is equal to 1. Okay, comparing the dimension of t. So from this equation we can easily find out the value of b, that is minus b is equal to half. So putting the value, we get a equal to positive half. Now a and b we take as an arbitrary constant, so easily comparing the dimension in the both side, we easily find out the magnitude of a and b. Now just put the value. So t is equal to k l to the power half and g to the power minus half. So the relation is t is equal to k root under l by g. So this is the relation between time period, length and acceleration due to gravity. Okay, so in this way, using dimension we can find out any relations. Okay, suppose now we just find out simple, we want to take one example, like we take find out t, okay, in terms of f and l, suppose, and also you can take as v also. Okay, so here actually f is equal to simple force and l is equal to length, whereas v is equal to velocity. Okay, and t is equal to time. So here we have to find out time period in terms of force, length and velocity. So similarly we just write down t is equal to k f to the power a, okay, and l to the power b, and actually v to the power, we just use v to the power c. So now we have to find out the dimension. Okay, so you just use force means ml to the power minus 2, okay, to the power a, and l means l to the power b, and v means l to the power minus 1 to the power c. Now what is the relation? We get k, okay, m to the power a, l to the power a plus b plus c, and e to the power minus 2a plus b minus c. So comparing both sides, we can easily say that a to the power actually 0, okay, because in the left side there are no quantity, that is mass, okay, and a plus b plus c is equal to obviously 0, and similarly minus 2a plus b minus c is equal to 0. Here if we put a is equal to 0, that means b minus c is equal to 0. So we can say that actually this is not 0, this is 1, I think. The right side you just use equal to 1 equal to 1. So from this relation you can say that from this relation a is equal to 0, that means b plus c is equal to 0, and another one is b minus c is equal to 1. So solving the relation b plus c is equal to 0 and b minus c is equal to 1, that means actually if we add two relation 2b is equal to 1, okay, so b is equal to half. Putting this value we can find out c, okay, so in this relation c means actually minus b, that is equal to, we can take c is equal to minus half, okay. So from this relation we just get three value, a is equal to 0, okay, and then b is equal to half, and then c is equal to minus half. So using this relation we can find out t is equal to k, okay, f to the power a means 0, okay, l to the power b, that means actually half, and v to the power minus half, or you can take as t is equal to k f to the power 0 root under L by V. This is also one relation. So in this way, using dimension we can easily find out different relations, okay, between different quantities also. Now we move to our next application, that is very important application, convert one unit system to another unit system, okay. So first of all, actually, we already take one simple example. Like we already know that what is the relation between Newton and dyne. Already we know that 1 Newton is equal to 10 to the power 5 dyne. Okay, so we already know. Now the question is how we establish the relation with the help of dimension. Okay, actually we have to know what which quantity actually has the unit Newton and dyne force. So as Newton and dyne it is actually for force, so we have to know what is the dimension of force. Dimension of force is ml to the power minus 2. Now using the relation or using the dimension, we can easily find out actually the relation between 1 Newton is equal to how much dyne. Okay, so at first we take 1 from this problem. At first we take 1 Newton is equal to x dyne. So find out x. Okay, so here you just put 1 Newton is equal to x dyne. Newton means dimensionally you just write down m1, okay, l1 and t1 to the power minus 2 is equal to x m2 l2 e to the power minus 2, and here you just find out x is equal to, you can take that m1 divided by m2 l1 divided by l2 into t1 divided by t2 to the power minus 2. Here m1 actually mass, okay, in which system? SI system. That means m1 in kg and m2 in gram, and l1 means in SI system it is meter, and l2 is in CGS system length, and time for both case same, so you can take as second by second to the power minus 2. So if you replace kg into gram, then you just find out 1000 gram by gram into 100 centimeter upon centimeter, and second is actually cancel, so we just get gram cancel and centimeter cancel, so we get x is equal to 10 to the power 5. So in this way you just write down the relation, that is 1 Newton is equal to 10 to the power 5 dyne. So in this way you can easily find out different relations, or you can easily convert from one system to another system for different quantities. Okay, so these are the rest two applications of dimensions. Now we move our next part, that is significant figure. So at first, what is the definition of significant figure? Actually significant figure means the numbers of digits up to which one could express a quantity measured. Okay, like suppose if we take actually different case. So first one, all non-zero digits are significant. That means if I take suppose 323, so its significant figure is a how much? Actually its significant figure is 3. Okay, so all non-zero digits actually are significant. Second one is, if I take any decimal digit like 3 or 4.20, here you can 203. Okay, here you can take as significant figure is all the digits 1 2 3 4, so significant figure is 4. Now the third rule is actually if I take one decimal point and then 007, here you can say in the right side of decimal point 20, okay, placed, okay, before the starting of the first digit. So here you just take only 7, that means here significant figure is only 1, because this is the rule. If there is no number in the left side of decimal point, okay, just we take 20 digit in the right side of the decimal, and then first non-zero digits are coming, then you just take significant figure as 1, like point number 4.0072, here you also take significant figure is 2. Now if I take 1.0072, then what happened? Then you can count all the 0 also. So here significant figure is 5. Okay. So total 5 digits are counted as significant figure. Now if in some digits there are actually units, so and also 10 to the power actually 10 to the power, that means power digit. Like suppose if I take as like 277.0, okay, kg. Now what is the significant figure? What is the significant figure? Here you can just take as only 4, okay. So here you just take as 4 significant, okay. If actually if kg is not mentioned, okay, you take 277.0, okay. So this is very important, okay. And the another thing, that is if some power is actually happened, then we just count, only from, like suppose here we take as 11.25 into 10 to the power something uh, 2, okay, kg. So here significant figure only you just take as how much? You just take as only 4, okay. So only these digits are counted as a significant figure. So these are the rules, okay, behind a significant figure. Now we move our next portion, that is some rules for arithmetic operations with significant figures. Like if I add or subtract something, like here you can take actually for addition and subtraction the final result, actually the you can see here the final result should retain as many decimal places as there are in the number with the least decimal places. Like here we take three numbers 1.3, 2.76 and 3.071, and we just add and get actually 7.131, because from this case maximum up to decimal here after decimal point we take this is 3 digits here. So you just add and you get 7.131 meter, and it is actually rounded off up to smallest number. Here you just see the smallest number only 2 digits, so you just rounded off up to 2 digits and you get the correct answer, that is this is 7.1, okay. And for multiplication and division, the final result actually should be as many significant figure as there are in the original number with the least significant figure. Here also you just, if you actually product, if you multiply two decimal digits, actually you just find out the answer at first up to maximum or many significant figure, then you just take original number with its least significant figure, like addition and subtraction. Next we have to move our third point, that is rounding of the uncertain digits and determining uncertainty. First one is, these rules are known I think for all of you. Rule number 1, okay, if the digit to be dropped is less than 5, then the preceding digit is left unchanged. Like 9.83 is rounded off as 9.8 because 3 is less than 5. Rule number 2, if the digit to be dropped is more than 5, then the preceding digit is raised by 1. Like 6.38, 8 is greater than 5, that's why we take rounded off as 6.4, okay. We just add 1 with 3. Rule number 3, if the digits to be dropped is 5 followed by a non-zero digit, then preceding digit is right by 1. Here you just actually find out 5 second digit, and the before the 5 we just get non-zero digit, that's why we just add 1 plus 1, that's why we get 14.3, okay. 2 plus 1, that is 14.3. Rule number 4, if the digits to be dropped is 5 but 5 followed by 0, then the preceding digit is left unchanged. Here you can see 6.250 in the right side, actually 5 followed by 0 right side, so that's why no one is added with 2. Okay, 2 is left unchanged, that's why 6.2 is the correct rounding up. And the roll number 5, that is if the digit to be dropped is 5 or followed by 0, then preceding odd is raised by 1. Here you can see that 9.750, 5 followed by 0, but in the left side the odd digit 7, so we just get rounding of like 9.8. In the previous one, actually in the left side of 5 it is even, that's why actually 2 is left unchanged. Here 7 is odd number, that's why it is raised by 1. Okay, this is rule number 5. And now we move to our next part, that is rules for determining the uncertainty in the results of arithmetic calculation. Here also you just take different rules, and at first we take one example, the length of breadth and the length and breadth of a thin rectangular sheet take as in meter scale 18.2 centimeter and 14.5 centimeter. This is L length and this is breadth. So if we want to find out the error or uncertainty or error in the estimation of the area of the rectangular sheet, so at first we have to find out normal area. What is the area? Simple, actually original area, that means length into breadth. Okay, now here you can see 18.2, so that means actually after decimal point we take one digit, so here we just error part we take 0.1 centimeter. Okay, in length. Similarly for breadth we take 0.1 centimeter. Okay, now we just get, this is the length value and this is your breadth value. Now you have to find out area, so by product L and B we just get this value 263.9 centimeter square. Okay, and 1.2% is the error. Okay, and the final result is actually after rounding up we get to 64, and this part actually we take as 1%. Okay, so in this way we can easily find out the error part of actually area. So at first we have to find out the error. Okay, for individual error for calculating length and breadth, then we just find out product length and breadth and we get area, and also we get percentage error of area. So now the problem is we have to know about error. Okay, so at first we have to know error part. So now we discuss with error. Okay, here you can see. Okay, in generally error means actual value minus measured value. Okay, suppose we actually find out length of a rod and the actual value is like 5 centimeter. Now anyone actually find out the length of the rod like 4.9 centimeter. Okay, so what is the error? Simple, 5 minus 4.9, so we get actually 0.1 centimeter is the error. Similarly, if anyone find out 5.1 centimeter, okay, in this case also error is 0.1 centimeter. So in this case actually negative and in this case positive, that means we actually write down error means, or we can express as L is equal to original value plus minus actually del L. Okay, del L act as error. Okay, now here you just see that different types of error, like systematic error in the part, instrumental error, okay, imperfection in experimental technique or procedure, and third one is personal errors like carelessness in taking observation, improper setting of the apparatus also, and random errors that is occur due to actually fluctuations in temperature, voltage, atmospheric pressure also sometimes. Okay, and the three, that is least count error, it is actually basically error arise due to instrumental. instrument. Okay, in generally we if we find out different quantities, so we have to take some different instrument. Okay, for different instrument there are several actually errors, or there are different types of errors. So in this case, least count error means actually error associated with the resolution of the instrument. Okay, and the last one is the personal error. Okay, personal error arise due to fault of an observer in taking, reading, lack of proper setting of the apparatus. Okay, so here you just see absolute error, that is if suppose L is expressed, length is expressed L0 plus minus del L, then you can take as error, that is del L is the absolute error. Okay, and also you can take relative error, that means actually relative error means absolute error upon original value, and percentage error means relative error. Okay, percentage error is equal to relative error into 100%. So in generally you have to remember three things: one absolute error, second one relative error, and third one is actually percentage error. Okay, so here you can easily see that what is absolute error. Simple here, the difference between arithmetic mean value, okay, of the different measurement and the individual measure value of the quantity. So this is the definition of absolute error. Okay, in the next class, actually this is the end of today's class. In the next class we discuss about different types of error. Okay, when addition, subtraction, multiplication, division occurs, then how we have to actually, how we can find out error in different situation. Okay, that is the actually discussed in the next class. Okay, so this is end of today's class. Okay, and thank you.